Lesson 6.4, Applications of Proportions, page number 469. We're just going to take the stuff that we learned in the last section and give you a bunch of story problems to figure out how in the world this is useful in real life. So let's start out with example 1. Woman drives her car 270 miles in 6 hours. Per, or in, 6 hours. If she continues at the same rate, how far will she travel in 10 hours? So we have miles and hours. We're going to put an equal sign and another line, and we're going to put hours down here and miles up here, just like we did over here. Got to compare apples to oranges, or miles to miles, and hours to hours. All right, what we're interested in is she goes 270 in 6. How far does she go in 10? So there's our equation. 4 different parts, 3 numbers, and 1 variable. Will always be that way. We do our cross multiplication, 270 times 10. And our cross multiplication this way. Divide by 6, divide by 6. And we find out that our x then is 2,700 divided by 6 is 450. So 450 is going to go right there. So if she figures out that she made 270 miles in 6 hours, she stopped and got a hamburger, and she's like, oh man, I've got this many more hours to go. How many more miles, or this many hours to go? How many miles am I going to be able to get out of the way? So she may be like, I'm going to drive a long day. 10 more hours of driving, I can get another 450 miles. So let's look at example 2. We get a baseball player that gets 8 hits in his first 18 games. Alright, if he continues at the same rate, 8 hits per 18 games, how many hits will he get in 45 games? So he may be interested. If we have 45 more games left in the season, how many hits am I going to get? Well, we've got x here. We don't know what that is. We do our cross multiplication. 18 times x equals 8 times 45, which is going to be 360. Divide by 18, divide by 18, x equals 20. So if he keeps going at the rate he's going, he's going to get 20 more hits by the end of the 45 games there. If we look at example 3 on page 470, get this erased here. We're talking about chemistry here. And in this particular one, water and alcohol. So a solution contains 4 milliliters of alcohol. 4 milliliters of alcohol. And 20 of water. So there's my ratio. 4 milliliters of alcohol for every 20 milliliters of water. So our container has 24 milliliters of solution, 4 of those being alcohol, 20 of those being water. If another solution is to have the same ratio, put an equal sign in a line, talking same ratio. And it must contain 25 milliliters of water. So bigger quantity here, but we want the same ratio. How much alcohol should it contain? So we don't know. So x milliliters of alcohol. We do our cross multiplication. 100 multiplying these, and 20x multiplying these. Divide by 20. Divide by 20. 5 equals x. So in order to make the ratio the same, if we have 25 milliliters of water, we're going to need 5 milliliters of alcohol. Which brings us to a last example here. These lessons go pretty fast. For some reason, they've really shortened them up in the book here. Some of these would take 3 tapes, in order to get them done. These are only taking about a half of one. Alright, example 4. The scale on the map indicates that 1 inch on the map corresponds to an actual distance of 85 miles. So 1 inch to 85 miles. Notice in the solution in the book, they have 85 miles over 1 inch. Just to let you know, it does not matter what how you finagle your ratio. So I just put 1 inch to 85 miles. Doesn't matter. There are two cities 3.5 inches apart. Notice 3.5 inches apart. I'm going to put 3.5 inches here because I have inches on top here. Now if I would have flipped it around like the book, the 3.5 inches would have gone on the bottom with the 1 inch. So like I say, it doesn't matter as long as your units are the same. So obviously I'm going to have miles down here. What is the actual distance between the two cities? How many miles is actually between the two cities? Alright, 1 times x is x. 3.5 times 85 is 297.5. So that's how many miles there are between the two cities. Okay, so let's look at some problems here on page number 471. See if we can get a couple of those done. There are a whole bunch of problems, but they're all done the same way. They're all dealing with ratios. So if you look at number 12, a child is given a prescription for 9 milligrams of a drug. So there's my prescription, 9 milligrams. If she has to take 3 chewable tablets, what is the strength of each tablet? So she's given 9 milligrams. Well, how many tablets is this kid given? 3. So what I'm interested in is what is the strength of each tablet? How much is 1 tablet? So how many milligrams? So I take 3x equals 9. My x then is 3. So there's 3 milligrams per tablet. So that's all there is to that one. Let's keep moving along here a little bit. Find something that doesn't have the... Alright, number 19, page 472. Traveling salesman figure it costs him 55 cents per mile to drive his car. How much does it cost him a week to drive his car if he travels 570 miles a week? Okay, so he's going 570 miles. And I want to know how much it's going to cost him. I don't care how long he's going to be gone, that it's a week, 10 days, or whatever, because we're comparing cents with miles. That's all I care about. I don't care about how far he's gone, except for the fact that he drove 570 miles in a week. So what I'm looking for is how much did it cost him to drive that 570 miles. So I multiply this across. 55 cents times 570 gives me $313.50 per week to drive that car. Okay, let's look at 21 real quick. 9-ounce serving of pasta contains 150 grams. So 9 ounce contains 150 grams of carbs. So I know that I'm going to have ounces on top and carbs on bottom. How many grams of carbs do 15 ounces contain? So it's real easy if you write your unit here over the unit here, put an equal sign, and put the same unit here, because then you know where your number and where your variable goes. So you end up with 9x equals 150 times 15, and then you will multiply these and then divide by your 9, and you'll be done.